My people, welcome back to another video lesson with yours truly, Mr. Kozad. I'm sorry I couldn't be with you for this lesson, but you get to still experience how awesome this lesson is. I just want you to know, as awkward as you might think it is for you to be watching this video wherever it is you're watching it, I promise you it's more awkward for me because I am teaching this lesson to an empty classroom, and that makes me feel a little uncomfortable. It's totally fine with me. I'm okay being comfortable for your expense, and I believe that doing this video is what's best for you. So here we go. Here's what you're going to need for this lesson. I would probably have a graphing calculator if you have one available to you. Probably a sheet of graph paper would be beneficial for today, and definitely whatever you take notes in, whether it's a notebook or a binder, or wherever you have your notes for this class, have that available for you as well. Okay, so let's jump right in. Chapter 6. If you have any questions as we go through this, just raise your hand and ask. Don't actually raise your hand and ask because there's no one to call on you. I was just trying to squeeze in a little joke there. Okay, 6.2 is our section here. So 6.2 is on inverse functions. Okay, it's on inverse functions. So here's where we're going to start. Here is, if I don't teach you anything else in this video, okay, other than this is totally important. Okay, maybe the most important thing that you're going to hear today. When you hear the word inverse, when you hear the word inverse, you either hear it or you read it. Here's what I want you to think. In your brain, this is what I want you to think. I want you to switch x and y. Switch x and y. Now, there's a lot of textbooks that are going to explain inverse functions a lot more in depth than this, and I've kind of watered this down. In fact, there's some math teachers and textbooks that would probably scoff at me for having you think like this, but I really believe that this kind of narrows it down to a really easy thing for you to remember that really kind of gets you at the core of what an inverse function is. Okay, so when you hear or read the word inverse, here's what I want you to think. Switch x and y. Switch x and y. Okay, that is so critical for you to remember. Okay, a couple other reminders that I would give you. Okay, a couple other reminders. Please remember that y and f of x you treat the same way. Remember that y and f of x can be treated the same way. So yeah, when I say inverse, I want you to, in your brain, think switch x and y. Some of the problems that we're going to deal with, in fact, all of them today, are going to be in function notation. It's the same thing. Switch x and f of x. You'll see what I mean in just a minute. Okay, you'll see what I mean in just a minute. Okay, another point that I want to draw out for you is the notation that we're going to use for inverse functions. If you're given it in y notation, if that's the function, so let's give ourselves some columns here. So if this is our function in y notation, the inverse, here's what's the notation you're going to use. The inverse will be y to the negative 1 power. Generally speaking, exponents that are negative 1 indicate to us the inverse. Okay, so we have y is the original function, y to the negative 1 power would be the inverse. So if we used function notation, here's what that would look like. F of x would be the function given for you. And here's what the inverse would look like. F to the negative 1, and then x, we'd read that as the inverse of f. The inverse of f of x, to be more specific. Okay? So that's kind of the basics. Let's recap again really quickly. When you hear inverse, I want you to think in your brain every single time, switch x and y. Also remember that y and f of x you can treat the same way. They're interchangeable. Okay? So with that being said, if it's given to you in y notation, the way that you would show that you're talking about an inverse is y to the negative 1 power. If it's given in function notation, the way that you would represent the inverse is f to the negative 1 power of x. Okay? All right, let's jump right in and get some example problems done. Okay, the first problem that we're going to look at together is how to find the inverse of a linear function. So we'll define f of x as 2x minus 5. We're going to keep it really simple for this first problem, and then get a little more complicated in problems 2 and 3. Okay? So f of x equals 2x minus 5. The first thing that I would look at here is I would identify which family of functions this comes from. Clearly, hopefully, you have a resounding consensus that this family, the family of functions that this comes from is the linear family. This is a linear function, 2x minus 5. Okay? And if you have a linear function, the inverse of a linear function will also be linear. So you know if you do this right, the inverse function that we're going to get is going to be linear as well. So what we're going to do is we're going to do what I reminded you of earlier, is we're going to switch x and y. Now the problem here is that no, I don't actually have a y here, but remember I told you that f of x and y can be treated the same way. So the very first thing that I'm going to do here is I'm going to take x and f of x and I'm going to switch them. So I have x equals 2 times f to the negative 1 of x, because I'm finding the inverse function, minus 5. Okay? Once you do this, this is honestly probably the hardest part of this particular problem, is just making the switch right at the beginning. So then all you have to do is you have to get the inverse of f all by itself. So you can actually do that in 2 steps. Step number 1 would be to add 5 on both sides. Step number 2 would be to divide by 2 on both sides of the equation. Okay, so I'm going to actually do those concurrently, because I think you're capable enough to handle that. You should be, at least. So what we have is the inverse of f of x equals x plus 5 all over 2. The inverse of f of x equals x plus 5 all over 2. So if we put it all together, if I gave you the original function, f of x equals 2x minus 5, and asked you for the inverse, you would tell me that the inverse of f of x is x plus 5 over 2. Okay? The next thing I'm going to ask you to do is actually create a graph for me. Okay? So if you have your own graph paper, now would be a good time to get that out. If not, you can sketch a pretty good graph right there on your notebook. Okay? I can't see the screen. I hope I'm still on the screen and not off, and you don't just see my arm. Okay? So here we go. We're going to sketch this graph. So let's start by drawing the first graph here, 2x minus 5. Now, if you have graph paper, you can do that really precisely. If you don't, like I don't, I'm going to do just kind of a rough guess here, a rough approximation. So I'm going to start with my y-intercept of negative 5. So I'm going to come down about right here, and that's probably about negative 5. And then what I'm going to do is I'm going to figure out, I've got my slope of 2, so I go up 2 over 1. Okay, up 2 over 1, something like this. Okay, that's a pretty good line. Okay, I'm actually going to extend this out just a little bit more here, just to kind of extend it out through the entire body of the graph that I drew here. So this, again, let's label this. This is f of x. It's f of x. Now, the next thing that we're going to draw is actually not the inverse function, but we're going to draw the line y equals x. We're going to draw the line y equals x, and I'll tell you why in a minute. So if I draw in, that's out of ink. Hopefully I got some luck with this one. If I draw that line in, y equals x, the line y equals x is a diagonal that cuts through the first and third quadrant. And let's label that y equals x. The reason that I had you draw that line is graphically what you're going to look for with inverse functions is the original function and its inverse will be reflected across the line y equals x. So that's a good way to always check to see if you graph this correctly, is did the original graph and the inverse, do they look symmetrical across the mirror line of y equals x? That should be the line of reflection. Okay? So now let's go ahead and let's graph the inverse function, x plus 5 over 2. Now I'm going to start with my y-intercept of 2.5. So that's up here approximately. Okay, that's up here. And my slope here is 1/2. Okay, my slope here is 1/2, meaning I go up 1 to the right by 2. Up 1 to the right by 2. So if you do this right, you should have a function. Okay, and if I label this one, this is the inverse of x. Okay? If you take a step back and kind of look at your graph, if you did this correctly, you should see 2 lines that intersect at the same point on y equals x that are reflections of each other. Okay? You should be able to look and see the symmetry. Okay? If you drew a line that was not even remotely close to symmetrical to the other one, with the line y equals x through the middle, you drew it wrong. Okay? So you need to double check that. But again, visually what I'm looking for here is a function and its inverse are reflections across the line y equals x. That is every single time, every single function, its inverse will be a reflection across the line y equals x. Okay? So that is our first problem. When we have a linear family of functions, the inverse will also be linear. Okay? Well, now we've got, we're getting to the fun stuff. Okay? Now we're going to look at what happens when we're given a quadratic function. Okay, so example number 2 is what happens when we're given a quadratic function. Alright, so here our function is going to be f of x equals x squared minus 4x plus 2. F of x equals x squared minus 4x plus 2. Okay, so if the directions are to find the inverse, okay, of f, here's the deal. If you have a quadratic function, the inverse of a quadratic function is going to always be a square root function. It's always going to be a square root function. Okay, so the inverse of the quadratic will always be a square root function. Okay, now here we go. Let's go through and actually find this algebraically. So the first thing that I want you to do is remember when you see and hear the word inverse, the thought that should be going through your brain is I need to switch x and y. Switch x and y. Now this one's a little bit different than example 1 because we actually have 2 values of x here, or 2 places where x occurs. So here's what you're going to do. Everywhere where you see an x, you're going to replace it with the inverse of f of x. And everywhere where you see f of x, you're going to replace that with an x. So here's what it would look like. I'm just going to simply rewrite this having made those changes. X equals the inverse of f of x squared minus 4 times the inverse of f of x plus 2. Now I'll make a confession with you. I think this particular problem would be a lot easier if we used, instead of function notation, if we used xy notation. So I'm going to go ahead and just rewrite this. Instead of using the inverse of f of x, I'm just going to use y. So here we go. I'm going to do x equals y squared minus 4y plus 2. It's going to be a lot easier on us if we make that change, and then we can actually go back to function notation at the very end. Okay? So this is where this problem really gets spicy, my people. This is where it gets really tough, because what we actually have to do here is we have to get y all by itself. And this is going to make some of you groan and complain. It's a good thing you're not in the room right now and you can complain all you want because I'm not with you. But here we're going to actually have to do completing the square. America's favorite, completing the square. So here's what we got. Okay, when we complete the square, we're looking to make a perfect square trinomial. A perfect square trinomial. To do that, we take our b value and we divide it by 2. So negative 4 divided by 2 is what? If you said negative 2, it's not weird. Okay, you're actually following along. That's good. So negative 4 divided by negative 2, negative 4 divided by 2 is negative 2. And then to figure out what I add here, I'm going to take negative 2 and square it. So negative 2 squared is positive 4. Okay? Now, hopefully you remember when we did completing the square back first semester, that if I add 4 here, I can either subtract 4 on the same side of the equal sign, or if we come over here, we can add 4 to the other side. Remember, this equation is in balance. And if you add 4 to one side, it's not balanced anymore without adding 4 to the other side to get it to balance out. Okay, so like I said, you can either subtract 4 on the same side or add 4 to the opposite side. I'm going to go ahead and add 4 to keep that balanced. Okay, so now what I do next is I'm going to take this 2 and I'm going to subtract it on both sides. So I get 2 plus x equals y minus 2 squared. Now I'm going to stop there because I probably lost some of you and you're thinking, Cosette, how did you get from here to here? Well, you got to remember how to complete the square. And if you need to pause in here and go back and spend some time figuring out how completing the square works here, that's a great time to do it. The purpose of this video is not to teach you completing the square. I've already taught you that. So go back and look that up. Okay? But if you created this perfect square trinomial, this factors to y minus 2 quantity squared. So hopefully you can start to see we're getting closer to getting y all by itself. Okay? So here's what we're going to do next. If we want to get y all by itself, we need to get rid of the 2. So we're going to square root both sides. So what I've got here is I've got plus or minus the square root of 2 plus x equals y minus 2. Notice how I introduced the radical because I took the square root of both sides. I lost the exponent of a 2. And remember, when we take the square root, you need the plus or minus. So then I'm really close. All I have to do is add 2 on both sides. So I get y equals 2 plus or minus the square root of 2 plus x. Y equals 2 plus or minus the square root of 2 plus x. So if we wanted to go back and actually convert this back to function notation, I would simply erase the y, and I would go back to function notation to say f to the negative 1 power of x, the inverse of function f, equals 2 plus or minus the square root of 2 plus x. And that is your inverse function. Okay, that's your inverse. So if we actually looked at this graphically, this is a little bit more complicated to graph, but I'm actually going to turn this over to you and let you do this on the graphing calculator. Okay, if you have one, that's great. If you don't have a graphing calculator, plug this in when you get into class next time. But here's what I would have you enter. For y1, I'm going to have you enter the original function, x squared minus 4x plus 2. For y2, I'm going to have you enter the reflection line, which if you remember from the last problem, is y equals x. Now here's where some of you are going to be a little confused. What we need to do for the inverse function is we can't actually in the calculator input the symbol plus or minus. So you actually have to, in the calculator, split that up into 2 separate functions. So the one that we'll input, y3, will be 2 plus the square root of 2 plus x. And then y4 would be 2 minus the square root of 2 plus x. So if you type these 4 graphs into your calculator and look at your graphing screen, what you should see is you should see the original function, and the combination of these 2 functions should create 2 parabolas that are symmetrical across the line y equals x. If it didn't work, come in and talk to me and I'll show you maybe how to adjust your window or how you're inputting something incorrectly to see how that works. Okay? If you need to go back and rewind and rewatch any of that, that was a pretty heavy problem because we did some completing the square and we haven't really had to split up square roots like this into 2 separate functions when we graph them. But that's what we got to do here on example 2. Okay? All right, one more problem we'll do together, and then we're actually done with this one for today. Number 3. So let me get rid of this. Isn't this fun? Number 3. All right, example number 3, the last one we'll do together. We're going to look at a square root function now. F of x equals the square root of 2x minus 1 plus 3. The square root of 2x minus 1 plus 3. Okay, here's what you need to notice. This comes from the square root family of functions. And one thing that will always be true is if you're given a square root function, the inverse will always be quadratic. The inverse will always be quadratic. Okay, there's going to be some pretty intense kind of nerdy stuff that comes up with this, with the concept of domain and range here in a little bit. So be ready for that. But the start of this problem really isn't that bad. Okay, so you know whenever you see inverse, you should think in your brain, switch x and y. Okay, so I'm actually going to do this problem similar to example 2. I'm going to do this in xy notation and then go back to function notation at the very end. It's just a little easier to write out. So I'm going to simply switch out the x and the y. So all I've done here is I did 2 things. I changed function notation to xy notation, which is fine to do, and I took the x and the f of x and they traded spots. So similar to what we did on example 1 and example 2, all I have to do now is algebraically rearrange this equation to get y all by itself. So ask yourself the question, what would you do first to get y all by itself? If you said or were thinking, you probably didn't say it aloud. If you were thinking, subtract 3 on both sides, you're exactly right. So we'll do that, and we get x minus 3 equals the square root of 2y minus 1. So now what we're going to do is we're going to get rid of the radical. If I want to get this y all by itself, I have to get rid of the radical next. And you should know from this last unit, we did this a lot. To get rid of the square root, we're going to square both sides. So we have the quantity x minus 3 squared equals 2y minus 1. You're starting to see it come together. Okay? I'm going to FOIL out the left-hand side, so I have x squared minus 6x plus 9 equals 2y minus 1. And then I can be done with this problem in 2 more steps. Add 1 to both sides, and then divide everything by 2. So here's what it'll look like. Y equals x squared minus 6x plus 10, because I'm adding the 1 to both sides. And I'm going to divide all of that by 2. Now, if you're somebody that would feel better going through and dividing each individual number by 2, that is fine. So it could look like this. 1/2 x squared minus 3x plus 5. Either one of those is acceptable for me. Okay, either one of those is acceptable for me. We should also probably, since the original problem was in function notation, let's change this out and let's write it in function notation as well. Again, some of you are probably uncomfortable with me just erasing the y and changing it to the inverse of f of x. They're interchangeable, okay? That's totally fine. So if I asked you what the inverse of f of x equals square root of 2x minus 1 plus 3, if I asked you the inverse of that function, you would tell me either one of these options. X squared minus 6x plus 10 over 2, or 1/2 x squared minus 3x plus 5. You've done the algebra to actually find the inverse. So now where it starts to get kind of nerdy is with the graph here. Okay, with the graph here. So if you were going to graph this, here's what I would do. I would have you, again, on the calculator, graph y1 equals the original function, the square root of 2x minus 1 plus 3. Now, if you have your own graphing calculator, you probably could graph this right now and look to see that, wait a minute, Cosette, that's not a parabola. Okay, if the inverse is quadratic, I know that that's going to be a parabola. But if I just graph this function, that doesn't give me a parabola. It only gives me kind of half of a parabola, okay, because that's a square root graph. Well, again, this is where it kind of gets nerdy here. So here's the deal. If you look back at this original function, you have to ask yourself a question. What are the rules on the types of numbers that the calculator can take square roots of? The calculator can only take square roots of 0 or greater, numbers that are 0 or greater. So what that means is the domain for this function, okay, the domain for this function is 2x minus 1 needs to be greater than or equal to 0, because you cannot, on the calculator, take a square root of a negative number. So here's what we do here. Okay, here's what we do here. We add 1 to both sides, divide by 2, and we get that x has to be any number greater than or equal to 1/2. That's my domain. So when you actually go through and graph the other ones, that's going to be important. We have y2, graph the line y equals x. And then for y3, you graph your inverse function. 1/2 x squared minus 3x plus 5. Now, like I said, if you actually graphed all these, what you would see is you would see half of a parabola that opens to the right. You'd see the line y equals x. And then you would see a full parabola that opens up. Okay, you might be asking yourself, well, hey, that's not symmetrical. Again, what you have to remember here is originally the function that you're given had a restricted domain. Okay, this graph is assuming that the domain is all real numbers. Okay, so you've got a domain here that's only x values greater than or equal to 1/2, but you have a domain here of all real numbers. So here's what I want you to do on your graph. If you actually take the domain for this function and you change it to the same as the domain that you had here, that you're only looking at the x values that are greater than or equal to 1/2, then you would see that you'd lose an entire half of that parabola, and you would see the symmetry across the line y equals x. Okay? Again, that's really, really nerdy, and I just feel a little bit better explaining to you the logistics to why you get half of a parabola here and a full parabola here. If that didn't make any sense to you, I promise that I'll try to explain it in more detail when we actually get back together in class. That in a nutshell is what I'd ask you to do today. So in class, what you're going to do is you're going to work on an in-class assignment where I actually ask you to do some of this on your own. Okay, so thank you for being with me. Thanks for enjoying the video. I hope that it was beneficial for you, and I can't wait to see you next class. See you, my people.